Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing stats number 3, organizing and representing data. In this section, we will discuss stem and leaf plots, frequency of data sets, relative frequency of data sets, cumulative frequency of data sets, and histograms of data sets. Let's get started by discussing how to display data and the definition of a stem and leaf plot. Displaying data. Definition. A stem and leaf plot is a type of display for data that retains the original or rounded data values from the data set. Stem and leaf plots are based on place values. Let's do an example with a stem and leaf plot. Example 1. A store manager records the ages of all customers who enter his store one day. The results are shown below. We want to create a stem and leaf plot to represent this data. And you notice all the data from 4 to 56 are the ages of the customers. So we can start a stem and leaf plot just like this. In our left column, we have our stem. And on the right column, we have our leaves. And our stems, in this case, we take the tens values for all of our data. So 0, 1, 2, 3, 4, and 5. And what we do is we create leaves in each of these stems for each data value. So I start in my list with 4. Well, the tens place for 4 is 0, so I put a 4 right here. Okay, so 4, and I can cross that out. And then 5 goes here also. 6, 9. Well, 10 can't go in the first stem, so it has to go with the tens value equal to 1. So we put 10, so 0. And we have 13, 15, 16, 18, 19, and then we jump to the 20s. So 23, 24, 25, and then 30, so 0. Another 30, so another 0. 38, 39. We jump down to the 40s for 44. 46, 48, 49, 50, 51, 53, and 56. So that is our stem and leaf plot. Now we want to ask and answer some additional questions related to this stem and leaf plot. Okay, number 1, we want to create a key for the stem and leaf plot below. Well, actually to the side now. The stems represent which place value? Well, as we said before, the stems in this case are the first digit, which is the tens. So, the tens. Each leaf represents which place value? Well, in this case, each of the leaves represents the ones place value. Okay, question 2. How many of the customers were younger than 49 years old? Well, we can create a line at 49. So we're looking at all the things less than 49. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 customers that were younger than 49. And number 3, what percent of customers were older than 50? Well, looking strictly older than 50, we go to 50 in our leaf plot, and there are 1, 2, 3. Well, we want a percentage here, so that's 3 out of the total. Well, how many do we have total? Well, there were 25 total customers. You can count the numbers in the stem and leaf plot to verify that. All of the leaves, there should be 25 total leaves. And 3 out of 25 is 12.12 or 12%. Okay, let's now talk about frequency tables and definitions. Frequency tables. Definition. Another type of table used for statistics is called a frequency table. Or frequency distribution. Frequency is a measure of how often something occurs. Relative frequency is the percentage of all the data in a particular bin to underline those. And finally, cumulative frequency is calculated by adding each frequency from a frequency table to the sum of its predecessors. Let's do another example. Example 2. A professor records the following final grades in one course. construct a frequency table for the grades. So we have A, B, 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 C, 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 D, 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 F, F. Okay, so we'll take these grades and we will create a table. So our first column will be the grade. In our second column, we will do frequency. In our third column, we'll do relative frequency. And in our last column, we'll do cumulative frequency. Okay, so our five possibilities for grades are A, B, C, D, and F. And then we'll have a total row. So how many A's did we have? Well, there are 4 A's. We have 7 B's. We have 8 C's, 3 D's, and 2 F's for a total of 24. So those are our frequencies. That's how many times each grade occurs. Now for relative frequency, we write that as a fraction. So 4 over our total of 24, and that gives us 16.7%. 7 over 24 gives us 29.2%. 8 over 24 gives us 33.3%. 3 over 24 gives us 12.5%, and 2 over 24 gives us 8.3%. And of course, our final total on the percentages is 100%. Our cumulative frequency is the total number of frequency plus the ones before it. So after the A's, we have 4. After the B's, we have 7 plus 4, which is 11. After the C's, we have 11 plus all the C's, which is 8, so 19. 19 plus 3 is 22. And 22 plus 2 is 24. And again, our total is 24. So that's how you would create a frequency table with these grades with relative frequency and cumulative frequency. Let's do another example. Example 3. The following data show the ages of recent Grammy-winning female artists at the time that they won their award. We want to make a frequency table for the data using the bins of 20 to 29, 30 to 39, and so on. And so here's the list of ages of the female Grammy winners. What we want to do is we want to create a table. And we'll need their age category. So we have 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 to 79. That's the highest age. We'll also need a tally column, a frequency column, a relative frequency column, and finally a cumulative frequency. So the first thing we want to do is we want to tally up which bins these ages fit in. So we have 34, 44, 69, 36, 38, 47, 46, 33, 36, 40, 46, 39, 40, 53, 30, 75, 58, 66, 44, 39, 46, 55, 48, 34, 57, 48, 33, 47, 51, 53, 64, 29, 21, and 53. Ran over just a little bit here. Okay, so now we can add those up. And for the 20 to 29 age group, we had 2. For the 30 to 39, we had 10. For the 40 to 49 group, we had 11. For the 50 to 59, we had 7. For 60 to 69, we had 3. And 70 to 79, we had 1. Create a total row. Just one more time. There we go. And so we have a total of 34 people. So in relative frequency, we get 2 over 34, which is 5.9%. 10 out of 34, which is 29.4%. For 40 to 49, we have 11 over 34, which is equal to 32.4%. For 50 to 59, we have 7 over 34, which is 20.6%. For 60 to 69, we have 3 over 34, which is 8.8%. And for 70 to 79, we have 1 over 34, which is 2.9%. If we add up all of those relative frequencies, we get 100%. Now for cumulative frequency, we add up the frequency total and the previous cumulative frequency. So for the first row, we just have 2, and then we add 10 to get 12. Then we add 11 to 12 to get 23. We add 7 to 23 to get 30. 3 to 30 to get 33. And finally, 1 to 33 to get 34, which is our total. That is how you create a frequency, relative frequency, and cumulative frequency table. That's all for this example. And now we'll move on to discuss the last topic for this section, histograms. Definition. A histogram is a graph that shows the frequency of numerical data using bars or rectangles. Okay, example 4. Our last example, we want to create a frequency histogram for the data in example 3. Okay, we want to create a frequency histogram for the data in example 3. So what we do is we've got our table here, our frequency table here, and then we have the plot for our we have the axes for our histogram. Notice this little break here, that means we're not starting at 0. Our tick marks at the bottom are by 10, and then on the vertical axis we have frequency in 1s up to 20. So what we can do is between 20 and 30 our frequency is 2. So we have a little line there, and we can create our box, our rectangle. For 30 to 39 we are at 10. And so we draw our box there. From 40 to 49, we are at 11. From 50 to 59, we're at 7. From 60 to 69, we're at 3. And from 70 to 79, we are at 1. Oops. One more time. Okay, so if you follow the rough path of this histogram, you can sort of see the way it would be shaped. And that's how we do a frequency histogram for the data in example 3. Pros and cons of histograms and stem and leaf plots. So why choose a stem and leaf plot? Well, stem and leaf plots contain the original data values. And histograms do not. Why would we choose a histogram? Well, histograms easily organize data of all sizes, no matter how big our n is, the number of observations, where stem and leaf plots do not. It would be hard to plot a stem and leaf plot with 1,000 observations. Okay, that is the end of stats number 3. Good luck on your homework. Please let me know and reach out if you have any questions, and I will see you in the next one.